I've actually been involved in trying to link agriculture to health for the past 40 years, and in fact, I was hired to do so by the U.S. Department of Agriculture. It's been a long and rough road, I must admit. Before I get focused on fertilizers in particular, I really want to ask this question, because I always ask it of my students at Cornell. You know, why does agriculture exist? And the answer is, of course, primarily because people need food. But it's not the food they need, it's the nutrients contained in the food they need. And I actually like to look at farmers as nutrient providers, not as food providers. Because if farmers don't get it right, then all societies suffer globally. The human body requires a minimum that we know of 42 absolutely essential nutrients. And these nutrients, if any one of them is removed from the diets of anybody for any extended period of time, that individual will become sick, and if long enough, will die, either directly or indirectly from that deficiency. So I view malnutrition, in particular, as a result of dysfunctional food systems that are based in agricultural systems that have never had an explicit goal of improving human health. And that's something that absolutely has to change. Agriculture's primary focus has always been on productivity, and within the last 20 years, some concerns for the environment has been dealt with. But there's never been a real concern for the health and nutritional quality of the products produced on farms. On the other side of the coin, we have nutritionists that look at malnutrition as a disease, and they want to treat the disease. They want to give supplements and fortificants. That's the Western medical approach. Unfortunately, neither of these attitudes is sufficient to find sustainable solutions to malnutrition. These strategies of supplementation and fortification, for example, don't address the primary cause of malnutrition, and that was the dysfunctionality of the system with respect to what agriculture was producing. And there's always these simplistic views, a silver bullet, we'll do this, solve the problem. Well, within food systems that are dysfunctional, and there's never any silver bullet that can possibly solve the problem. And I say finally that agriculture and human health have never been generally recognized as closely linked disciplines, but in fact, they are. Well, there's many things that we can do in agriculture, many tools that we have that we can apply to improving human health. Today we're focusing on fertilizers. Last week we focused on biofortification that Harvest Plus has been responsible for primarily in their global efforts. But we know that fertilizers can be used in ways that can promote human health, and I'll give you some examples here. The macronutrient fertilizer, we heard from Tom some of this, that you can apply these nitrogen, phosphorus, potassium, sulfur, calcium, magnesium in ways that can promote the beneficial attributes of the foods produced on the soils. Such things as protein quality, fats, the vitamins, the anti-nutrients, these things that interact with nutrients to prevent their absorption and utilization in the body. Promoter substances that can promote the absorption and utilization of the micronutrients that we're concerned about. For the micronutrient and trace element fertilizers, which I'll focus on in my talk, we know that some forms of fertilizers work well for some of the micronutrients and not so well for others. And I've just listed them there, the ones that works well for. In particular, I'll be talking to you today about zinc, selenium, and iodine. Well, it turns out if you get the micronutrient concentrations right in the edible seeds and grains, the major staples, those seeds and grains become more productive. So this is a win-win situation. You get improved productivity, and if the people eat these improved micronutrient-dense varieties that you plant and grow, you get improvements in human health. Also improvements in livestock productivity. So I just listed some things there that you find when you have improved micronutrient density in the seeds, because seeds require nutrients too, and the embryo, as it germinates, requires these nutrients. So the closer you get those nutrients to the embryo, the better chance it has of survival when it's affected by biotic and abiotic stresses. So you do see these benefits to productivity by improving the density of these nutrients in the grains and seeds. Okay, this is a study done by a professor from Duke University. His name is DeLong, and he's a pediatrician, and he donates his time in northwestern China, irrigated districts. And he noticed in his practice back in the early 1990s that he had large instances of iodine deficiency disorders. There was many children that were cretins. Cretinism is very large in the villages. Many people had goiters and other iodine deficiency disorders. So he went to the government and he asked the government, what are you doing about this, iodine deficiencies? And the government said, oh, we iodize the salt. We have iodine capsules. Well, DeLong said it's not working. So we went back to the villages and he asked, what's going on here? And they said, well, they didn't like the taste of the iodized salt. They preferred the desert floor salt they'd been eating for the last 5,000 years, and they wouldn't change to iodized salt. What about the iodine capsule? Oh, well, we don't trust the government. They're putting birth control substances in those capsules. Of course, that's not true, but that's the way they viewed it. So DeLong wanted to do something about this. So he had this brilliant idea. He got himself a 50-gallon drum, put a faucet in the bottom of it, filled it with water, and dumped in some potassium iodate. He went to the reservoir source for the irrigation system in the village, and he started dripping the iodine into the water. He had a control village where he didn't do that. And this is the data from that study, before iodine, after iodine. And you can see the iodine concentration in the wheat, other cereals, oil crops, vegetables, meats, eggs, and milk all increased dramatically in iodine concentration from applying the iodine to the soils and irrigation water. In villages where he didn't do that, the iodine concentration didn't change. Then he went and he checked the iodine in the urine, which is a measure of iodine sufficiency, and before he iodized the irrigation water and after. And he was able to show in the site where he did it that he was able to essentially bring the whole village population into iodine adequacy by this method. So it worked. But more importantly, and this is very important, the farmers saw a 30% increase in livestock productivity. The livestock needed the iodine too. So by going to the root cause of the problem for iodine deficiency, which is no iodine in the soil, he solved the systems problem. And that increase in livestock productivity made a great increase in the income in those family farms, which would allow them to start diversifying their diets. Now, if you started adding iodine to the salt and only the humans consumed it, you would have never had this systems effect on finding a sustainable solution to the iodine deficiency problem, which is the lack of iodine in the soil to begin with. Well, moving on, this is an example of another fertilizer applied to improve human health. This is in Finland. In the late 1980s, it was observed that the entire Finnish population had a very low selenium level, and this could lead to higher risks of cancer and other health-related selenium deficiency problems. So they passed a law in Finland that for all cereals and all fertilizer applied to those cereals in Finland, that the fertilizer would have to contain selenium. They did this and they showed that it worked, that they could increase the selenium by applying selenium fertilizer. This is just one example where you have a control site and two different forms of selenium, selenite or selenate. And you can see by applying it, you can get increased selenium in the grain, in this case of rice. So as a fertilizer technology, it works. But if you look at within 3 to 5 years, when they went back and studied the selenium in the blood of the Finnish population, they were able to double the selenium in the entire population by adding selenium to the fertilizer. So this is an agricultural tool that works. It's efficacious. It's efficacious for selenium. It's efficacious for iodine. This is zinc. Now, this is data from Ismail Çakmak's colleagues in Turkey, and just shows that if you apply zinc to a soil and by foliar spray, you can get maximum effects on increasing the zinc concentration in the grain. Not only that, but actually these zinc-enriched seeds have increased productivity on the Anatolia plain, which is very zinc deficient. You also get increased protection against nematode infections in those wheats that were grown from the zinc-enriched grain. So here again, it's another win-win situation. They're getting increased productivity, as well as those seeds now contain more zinc and that human population is now getting more zinc in their diets. And that should improve their health. We know zinc deficiency with diarrhea episodes and respiratory diseases now, very strong link. So I've thought for a long time now, if the world was really interested in getting rid of zinc deficiencies, which, by the way, is probably as serious, some people think, as iron deficiency, which is the #1 leading deficiency, micronutrient deficiency globally, that if we're really interested in getting rid of zinc deficiencies globally, we will use zinc fertilizers. And we can use crops that take more zinc into the grain as well, which we get through biofortification process. But the combination of both, we can get rid of sustainably, I believe, zinc deficiency globally. Okay, this is my last slide. I gave a congressional briefing here on the Hill a couple of years ago for the American Society of Agronomy, Soil Science Society, America, and Crop Science Society, and in conjunction with the American Nutrition Society. And this is what I came up with, these items for sustainable solutions to malnutrition. I think first we need to declare a goal of agriculture to produce high quality food that promotes human health and well-being in sustainable ways. We need to design seeds, cropping systems, and livestock systems that help achieve our primary goal, design for maximum nutrient output of farming systems. We really need to do that. We can genetically modify food crops either through traditional breeding means, or we can go to molecular biology and transgenic approaches if need be. That's become known as biofortification. I think that's a very important tool within the agricultural toolbox that could go in conjunction with fertilizers. I put here, use agronomic practices that improve nutrient output of farming systems, and that would include, in a large way, the fertilizers. And finally, here's something I get, some people don't agree with me on, but I think it's very important. If you start trying to define sustainable agriculture, you cannot divorce it from humans. So I say that sustainable agriculture needs to be defined as agriculture that yields healthy foods for healthy and productive people. That has to become part of the lexicon for sustainable agriculture. We need to form this link between agriculture and health in ways that is sustainable, because I'm telling you, all malnutrition has its roots in what agriculture is doing. And if you want to solve malnutrition globally, you're going to have to use all the agricultural tools within the agricultural toolbox. And the two that are very important is one, the use of fertilizers, and two, biofortification. They're two very good tools.